The biggest scientific mistakes in history. Science advances by making explanations, testing them, and replacing the ones that fail. Some errors were honest models, while others involved weak testing, fraud, prejudice, or political pressure. A wrong equation may waste a year, but a wrong medical or social theory can harm generations. These 10 cases reveal how evidence, replication, ethics, and open criticism protect science from itself. Mistake 1. The geocentric universe. For centuries, influential astronomical models placed a stationary Earth at the center of the cosmos. Extra circles called epicycles helped the model predict complicated planetary motion surprisingly well. Copernicus moved the sun near the center, while Galileo and Kepler supplied powerful observational and mathematical support. A model can calculate useful results and still describe reality incorrectly. Mistake 2. Bloodletting. For more than 2,000 years, many physicians believed illness came from imbalanced bodily humors. Bleeding patients became a common response to fevers, inflammation, and many completely unrelated conditions. For most conditions, removing blood offered no benefit and could leave already ill patients weaker. Early numerical comparisons helped show that routine bloodletting had far narrower value than tradition claimed. Mistake 3. Miasma theory. Before germ theory, many experts blamed epidemics on poisonous smells rising from decay and filth. During London's 1854 outbreak, John Snow mapped cholera deaths around one contaminated water pump. Removing the Broad Street pump handle became a famous demonstration of evidence-guided public health action. Later, microbiology showed that specific microorganisms cause specific diseases, transforming sanitation and prevention. Mistake 4. Phlogiston. 18th century chemists proposed that burning objects released an invisible substance called phlogiston. The theory struggled because some metals became heavier after burning instead of losing material. Antoine Lavoisier used sealed vessels and careful weighing to show that combustion consumed oxygen. Replacing phlogiston with measured elements helped create modern chemistry and the conservation of mass. Mistake 5. The luminiferous ether. Because sound and water waves need materials, physicists assumed light waves must travel through an invisible ether. If Earth moved through ether, light should travel slightly differently in different directions. The 1887 Michelson-Morley experiment found no expected directional difference in light speed. Einstein's special relativity explained light without a mechanical ether and changed ideas about space and time. Mistake 6. Piltdown Man. In 1912, fossil fragments from Piltdown, England were announced as an ancient human ancestor. The large brain case and ape-like jaw fitted what some researchers already expected human evolution to look like. Later tests showed a human skull had been combined with an orangutan jaw, stained and artificially altered. The hoax survived for decades because prestige, limited access, and convenient expectations discouraged stronger challenge. Mistake 7. Eugenics. Eugenics falsely treated intelligence, poverty, disability, and behavior as simple inherited traits. Biased social judgments were presented as objective biology, giving discrimination a false scientific appearance. Eugenic policies enabled forced sterilization, exclusion, and abuse against marginalized people in multiple countries. Good science must respect human complexity, consent, dignity, and equal rights, not merely produce measurements. Mistake 8. Lysenkoism. Soviet agronomist Trofim Lysenko rejected Mendelian genetics and claimed acquired traits could be inherited. Political leaders supported the claims, while critics and geneticists were dismissed, silenced, or imprisoned. Unreliable biological ideas damaged research and contributed to poor agricultural decisions for decades. Political power can suppress scientists, but it cannot make an unsupported biological claim become true. Mistake 9. Thalidomide. In the late 1950s, thalidomide was sold in many countries as a sedative and treatment for morning sickness. Exposure during early pregnancy caused severe birth defects and pregnancy losses on a devastating scale. FDA reviewer Francis Kelsey withheld United States approval because the safety evidence was inadequate. The disaster helped drive stricter testing, proof of effectiveness, and modern pregnancy risk controls. Mistake 10. Cold fusion. In March 1989, two chemists announced that tabletop electrolysis had produced nuclear fusion at room temperature. The extraordinary claim reached a press conference before the full evidence had undergone normal peer review. Laboratories worldwide rushed to repeat the result, but most could not reproduce the claimed heat and nuclear products. Government reviews found the evidence unpersuasive, making cold fusion a classic lesson in replication and restraint. These stories repeat four dangers: confirmation bias, weak measurement, closed criticism, and premature certainty. Independent repetition is not an insult to discovery. It is how science checks whether nature agrees. Controls, statistics, transparent data, and peer review make errors easier to detect before they spread. When research affects people, consent, fairness, and dignity are as essential as accurate measurement. The safest scientific sentence is sometimes, "This is our best explanation, but new evidence could change it." Subscribe for more history of science and comment which famous theory or experiment Nova should investigate next.